All right, so 2.3, we're talking about properties of functions, and almost, I would say like 80% of this you already know, okay? So a lot of it's review, but that's good for us because we really need to know this well. So the first part is regarding even and odd functions, which we already talked about basically. And here are some properties. So we say even functions. Even, so here's an example of even. Even is when we are symmetric to the y-axis, right? So an example would be like y equals x squared, which is like a nice perfect parabola. So if this point right here was xy, this point over here would be literally, if this is a perfect parabola, then it has symmetry. And then this would be negative x comma y. So this should be symmetrical on the other side in quadrant 2. All right, so that's why we have xy goes to negative x comma y. And then we're also saying that the y value, if you plug in a negative x, it gives you the same y value. So this means the same thing. We've kind of talked about this before. We know it's symmetric to the y-axis. For odd functions, remember odd functions is when you're symmetric around the origin. So you're symmetric going 180 degrees literally around the origin. It's like you're rotating around the origin. So if you start here, you end here. If you start here, you end in quadrant 4. So quadrant 2 would go all the way to quadrant 4, okay? So here's a little example of what a really nice x cubed would look like. So if this is xy, and you rotate 180 degrees, it ends up in quadrant 3. So you would get negative x comma negative y. So this part is basically saying, and this part is saying, we've already done this part, is if you plug in a negative x and a negative y, you get the same thing as if it's xy. So here I said, okay, if you plug in a negative x, it becomes a negative y, right? So if you plug in a negative x, you get a negative y. So that's what this is saying. Plug in a negative x, you get a negative y. But here you plug in a negative x, what do you get? You get a positive y, right? F of x is just like y. All right, it's symmetric around the origin, 180 degrees, and here's our little example for it. Okay, so here's a question that you should fill in. How come a function can't be How come a function can't be symmetric to the x-axis? So how come a function can't be symmetric to the x-axis? You know why, right? Okay, so you're going to write it down. So if a function is symmetric to the x-axis, it might be like a parabola going this way, and the problem with it is that it's not going to pass the vertical line test, right? So it's not a function anymore because it doesn't pass the vertical line test. Okay. So determine, ooh, there's a lot of, I want to block this, man. I know you see it, but, okay, I want you to write down this stuff first, okay? So determine whether the following functions are even, odd, or neither. So we've done this before, and you can do it the same way, but here's another way. So basically, what you can just do is you can plug in a negative x. You can plug in a negative x. If it gives you exactly the same thing, you have an even function. If it gives you exactly the opposite, you have an odd function. So if I plug in a negative x, let's see what happens. I would plug in a negative x, I'd square it, I'd get literally exactly the same thing. So that means that when I plug in a negative, I still get exactly f of x. So that means it's an even function. I do the same thing for the next one, plug in a negative x, and then think about what happens. What does this turn into? What does this turn into? Well, they're both going to become negative. And then really, we can pull out the negative. And isn't this exactly the same, but with a negative out in front of the whole thing? Well, that means it's negative y. All right, so there would be your odd function. Okay? So for C, go ahead and try it on your own. Actually do the plugging in. And if you actually plug it in, you get that. And then you look at it and you're like, is that exactly the same? No. Is that exactly the opposite with the negative in front of the whole thing? No. So that one's neither. You're going to try the last one. Don't just copy. You're going to actually plug in the negative, see what happens. You should pause it. And then, hopefully, you'll realize that when you plug in a negative, you get the same thing, you get the same thing, you get a negative here, which can be pulled out to the front, which is the same thing but negative in the very, very front, which means it's odd. Okay, so that's something that you guys have to practice. Don't just copy me. Okay, average rate of change. Guys, you know average rate of change. That's literally slope. So that's like old school slope. You got 2 points, you're finding slope. Okay, so I draw a picture, but this is slope, okay? So this is like more ways of thinking about the same thing. So the slope of a secant line. What's a secant line? A secant line goes through a curve at 2 places, basically. So that's a secant line right there. So I'm calling this C. So this is my x value, right? But I'm calling it C, comma, f of C. And then this I'm going to call x, comma, f of x, okay? Slope is the change in y over change in x, which means y2 minus y1, blah, blah, blah. I always say y sub x's. And then that means that it doesn't matter which way you go. You can subtract this way or you can subtract this way. But if you start with this point, then on the bottom you have to start with the x's also, okay? So f of x minus f of c all over x minus c. You can go the other way, but on the bottom you have to go the other way, all right? Okay, so there is slope. Find the average rate of change for that function from 1 to 3. Okay, that means that 1 is an x value, 3 is an x value. You plug in 1, you plug in 3, and you get 2 points. So you have to get those 2 points. You have to get an x and a y, an x and a y. And then you literally like use the slope formula, and then you get your slope, okay? Don't just copy me, actually like understand it. Okay, and then you try that one. And if you do that one, well, you already have f of 1, and then you find f of 8, and then you might use a calculator. Don't be a big cheater. And then you check the answer, okay? All right, so old school slope, but I want you to think of it in this new way, and then I'm going to show you something that happens differently with the old school slope. Okay, so this says, find the arc of, all right, this means find the rate of change. So different words, same thing. You have to know find the arc means find the average rate of change, find the slope of this function from -2 to 4. Go ahead and do it. You should do it. So plug it in, you get an x and a y, and then go ahead and find your slope. Okay, this one's interesting. This one you should for sure do. Okay, don't be a big cheater for this one. You should definitely do this. Okay, plug it in, plug in that -2, you already know what you get. Plug in that x, what do you get? Aww. You get the function, right? Don't you get the function? Okay, I want you to actually do this. Now, you're gonna do, so here was like f of 4 minus f of -2 over 4 minus a -2. You're gonna do the same thing here. F of x minus f of -2 over x minus a -2. Write it out, and you get that, right? So you get that function minus the y value all over x minus the x value. And then you clean it up a little bit, and then you start to realize some things like, oh, I can keep going. So you keep going, and then you realize some more things, and then you keep going, and then you get that. So basically what this is saying is, from -2 to any point, this is going to be your slope. Like right here, from -2 to 4, I'm going to cover this part. From -2 to 4, we did the problem, I know. But let's plug in a 4. So 4 is our x, right? Let's plug in a 4. 4 minus 2 is 2. 2 times 3 is 6. So this formula for slope gives me my slope from -2 to any number, which is really nice to have. So this one says, okay, what about -2 to 10? Okay, using this, I can plug in and I get 24. So I don't have to do the slope formula anymore because now I have this formula from -2 to any number, and I can just plug the 10 into that any number, okay? So a little different ways of thinking about it, like stuff that you know, like I said, but a little bit different. Okay, so then the next part has this beautiful picture. I hope that you printed this, but if you didn't, I'm really sorry. You're gonna like put your paper on top of, you know, the Chromebook and copy it, right? So copy that picture, and then I write a little note for you. It says local versus other things. So we're talking about like, a lot of times we're talking about a local versus like an absolute maximum or minimum. Okay, so we'll get to this in a second. All right, but this is really important. We'll get to it in a second. It says find the local max. I know it says maxima. That's just like plural for maxes. And local minima. All right. When you're finding a local maximum and a local minimum, you're basically finding all your maximums and all your minimums, right? So you're finding the very top of a hill. Those are your maxes. That should make sense. And the very bottom of a valley. Those are your minimums, okay? So a local, specifically a local, is when slopes change from positive to negative or negative to positive. So a local has to be the top of a hill. Specifically, is this a local maximum? The slope is positive and then it's 0. At least that's what it looks like, right? So is that a local? No, it's not a local max because this stays y equals 4 the whole frickin' time. Actually, what does it say? Yeah, 11,4. That stays y equals 4 the whole time. So that's not a local maximum, okay? So then we list all your local maxes and your local mins. So how many maxes? We had 3. How many mins? 1, 2, 3, 4. We had 4. So you list your points because those are points and you don't want to get them mixed up between points and intervals. Okay, so then there's this other word, an absolute maximum and an absolute minimum. Okay, so this gets a little bit tricky. So an absolute maximum is literally like, what is the absolute maximum value, basically a y value, okay? Because when you look at the top of the hill, the top, when you go up, that's a y value. So what is the biggest y value ever on this graph? So initially you might be like, that one, it's that one, Miss Tan, I see, it's the highest one. How come I say does not exist? Because if you look at the very left, there's an arrow that goes up. The right side just goes, you know, horizontally, but the left side goes up, up, up. So the left side goes even higher than y equals 7. That's why an absolute max does not exist. What about an absolute minimum? Okay, so do I go down here? No. Do I go down here? No. So what's my lowest y value? My lowest value here, my y value is 1. So the location, these are two different things, be careful. The location of my absolute min is at x equals -9. That's the location where x is -9. But the value of my absolute minimum value itself is y equals 1, is 1 specifically. Okay? So I know it gets a little bit tricky. Okay, find the domain and range. You can do that. Find the domain. Hopefully you said basically all real numbers. So then you write it like that. And then find the range. Remember for range, you smush it, like this is sand, so you smush it onto the y value, and then you look from bottom up. So think about what your range would be, and then check your range. Hopefully you said from 1 inclusive all the way to infinity, because this is the lowest value. We already said that. That's the lowest y value, and then it just goes up, up, up from there. So all of these smush onto the y value, and then this arrow tells me I just keep going up forever. There's sand all the way up there forever. Okay, so there's C. Okay. And then B, oh, I went in a different way. B, list the intervals of f in which it's increasing. So this is more like, this is like review of 2.2. So where are you increasing? Well, increasing would be positive slope, right? You're like literally, you have to increase to the right, by the way. Like it always goes to the right. So you have to, you're on a roller coaster and it goes in one direction only, okay? So you're increasing here and here and here and here. So there's 1, 2, 3, 4 intervals. And then where are you decreasing? There is, whoa, be very careful. You're decreasing here and here and here and here. So 1, 2, 3, 4. What's your first one? It starts with negative infinity. Be careful. And then where are you constant? You are constant right here. So you're constant on that interval. These are all intervals. These are all x values. See, these are points. I labeled them as points. If they're not points, they're intervals. That's why you want to always label your points. Okay? Find the intercepts. You have to find the x-intercepts and the y-intercepts. Well, there's just one. There's a y-intercept. And then is that it for that one? Yeah, that's it for that one. Okay, so you jotted all that down. Okay, the last part, you need a graphing calculator. So if you might have to pause this, but you need a graphing calculator. So you're going to put that into your graphing calculator, and then I already put it in here. So y equals, and I already put it into my graphing calculator. Okay, and then, you know, it tells you to graph it, but then really, if I try to graph it, it looks like that. That's not what I want. You have to make sure you read the question. This says that my x values go from -2 to +2. So my window for x's, I want to go from -2 to +2, but I kind of want to see what happens to the left and to the right. So I don't want to go to -2. I want to go to like -2.5, and then I want to go to like 2.5. So if you set it to that window, and then you graph it, it looks a lot better, and then you can see a lot more of what's happening in the graph. Okay? Okay, so then the next part is find the local minimum and maximum. Okay, so remember when we did zeros? Sorry, remember when we did zeros? We're going to do something really similar. We want to find this, and we want to find this. We want to find the point, and we want to find the point. Calculators can do that for us. It can calculate. Look, right here it says calc. So you're going to do second trace. Oh, look, it says minimum and maximum. So you calculate. Let's do minimum. So I'm going to press 3. This one's the minimum. So I scroll over to where I want to find it. I see this is the minimum over here, but I go to the left. See the left boundary. I go to the left of the minimum. I press enter. I go to the right of the minimum. I press enter. And then it wants me to guess. I press enter one more time. And I have that x value and that y value. And then I do it one more time to find my maximum. I'm going to show you the maximum, but you should be able to do it yourself, okay? So you can, fast forward through this if you want. So I'm going to find the maximum using number 4. And then I got to scroll all the way over. I always use left and right, never use up and down. And then I press enter. I go to the right of my maximum. I press enter. I press enter one more time. And then it gives me a maximum. And then that's my maximum. I will say, if you get this wrong, it's probably because you go like this and you pick 3 as minimum, and then you try to find this, and then you'll get the wrong answer because a minimum is way over here. Okay, so just be careful about like which one you're choosing and what you're trying to find. Okay, list the intervals in which f is increasing and decreasing. All right, it's increasing here and here. So it increases over those 2 intervals, and it increases until this x value, and then it starts again at this x value. But I already have those right here. So from basically, where does it tell me to start? Oh, it tells me to start at -2. So from -2 to this value, and then from here to +2. So I don't need any more stuff on my calculator. I already have those 2. And then where are we decreasing? We're decreasing right here. So we're decreasing in between, this one and this one, right? So it's just that one interval. Okay, C. Where do we have a 0 slope? It happens at 2 places, right? We have positive slope, and then it slows down and becomes 0. And then we have negative slope, and then it slows down and becomes 0. And then we have positive slope again. So it happens in those 2 places. So I'm just going to say those 2 points are my 0 slopes. And 0 slopes have to be, remember, they have to be nice and smooth. So zero slopes are when you're like on a roller coaster and you're coasting along and then you see the horizon. So you're like up at the very top and then it's nice and smooth and you see a horizon, then you come back down and then you see a horizon again over here. You're like sitting at the bottom of the roller coaster, but you're basically sitting like almost on the floor here, right? And then you go back up. So horizon and horizon over here. You're basically sitting so that your view is like over, you know, everything, and you see everything straight on, like you're kind of sitting on the floor but parallel to the floor. Okay? So that's a zero slope. If you break your neck, there's no slope. So like right here, this one, if you were on this roller coaster, you're super happy and then you're like, okay, broke my neck, I died. Okay? So there's no slope here. Everywhere else there's a slope. But right here there's no slope. All right, good luck guys.